We'll be fine. Okay.
Hey, Mondo, I'm gonna fail this quiz in baby
All right, here we go. Next problem on our agenda. We are still on review number 2, and we're ready for problem number 9, which is very similar to the one we just did. It is written differently. What does this mean? What does that mean? What am I supposed to do? Exactly. I'm supposed to plug the whole g function into the x's in f. And isn't that pretty much what I just did? It was written differently, but I am finding f of x plus 5. This is x plus 5. So that's going to be x plus 5 squared minus 2x plus 5 plus 3. All right, so take a second. We just did this. Take a second. You know what you need to do first. You need to FOIL. Select right terms. Let's see what we can come up with.
For some grapes. $4. Go talk.
There could be another complaint lodged. I don't know. We'll see. That does seem high. Grapes are expensive right now, but.
I wish I did at the grocery store for like a big
Great
bag.
market going on.
Well, they're like $3 a pound.
Yeah, that's definitely not a pound.
No, that's not a pound.
Back in the great market.
There's a bigger one than you bought. Same. Quit buying it, people. Quit buying it. All right, I got x squared plus 8x plus 18. Is that right? Anybody else get that? No?
I got 3.
Bless you.
I got that. You got that? What you get? I got x squared plus 3x. 3x.
I don't know how you get 3x.
Yeah.
Because when you FOIL that, you get 10x.
Well, let's do what you did.
And 10 minus 2 is
You're
8.
right. You do. I do get 10x.
Yep, you do. Yeah, I don't see a mistake. I think that's right. All right, number 10. Now, if you are asked to graph something, one option that you always have, always, in every class, everywhere, you want to graph something, you can set up a T-chart and just pick a bunch of points and figure it out. I don't think you need to do that in this one, because this is just a variation of one of your BFFs. What does this look like, your BFF? What does he look like? He's a parabola, vertex at the origin. Now, we've made some changes by putting stuff in to this equation. What does that do? Adding 2 to the x moves you left 2. So whatever's happening, this guy's gonna go left 2. What does that do to it? Down 1. So now I'm at -2, -1 instead of the origin. And then what does that do to it?
Okay.
That turns it upside down. So really, without too much difficulty at all, you can sketch that, just knowing what the transformations mean. All right, we did this yesterday. How do we find the vertex? We had another parabola. How do we find the vertex of this one? We did it yesterday. Negative b over 2a. So x equals negative b over 2a, which in this problem would be negative 6 over 6, which is negative 1. So wherever my vertex is, remember it's a point, I know the x coordinate is negative 1. And then how do I find the y?
Plug one in.
And when I plug it in, I do so carefully because I see this mistake all the time. Kids will say, oh, that's negative 3, and when I square it, I get 9. No, you don't. You square negative 1 and get 1, and then you times it by 3 and get 3. So this is 3 minus 6 minus 1. So that all adds up to negative 4. And there's my vertex. Negative 4. All right, number 12. Speaking of transformations, you're going to make your own equation. You're going to start with your regular quadratic, your squaring function, and you're going to shift it 1 to the left. So what are you going to put into your equation? It's going to shift this 1 to the left. Or, where am I even reading? It's horizontal shift left 2, right? Left 2. I want to go left 2. So what am I doing? So this is going to be plus 2. Don't forget the square. That moves me 2 to the left. Now I want to stretch it, not move it, stretch it, make it taller by a factor of 3. How do I do that? 3 in front. That's your vertical dilation, your vertical stretch or shrink right there. And then I want it to go down 1. Minus 1 at the end, and there's your equation. You went 2 left, down 1, and got stretched by a factor of 3. Okay, so we kind of talked about this yesterday, just a little bit. What do we mean by decreasing? We want this function to be decreasing. So what does that mean? Going down, right? So look at the picture, maybe even start tracing it right here. Right off the bat, aren't I going down? So that first piece of the graph is going down. What are the x values? We always write this as x values. What are the x values for that first piece of the graph? Where do I start? X is negative 3, and where do I stop? Negative 1. So there's the first piece of the graph that's going down. When you list your intervals, it's always x, always x, always x, okay? Now, is there any other part of the graph that's going down?
1 to 4.
Yes, there is, and it's the part, Matthew says, from 1 to 4. Would you agree with that? That's the part of the graph that is decreasing, going down. Increasing means going up. Do it the same way, but you look at the parts that are going up. All right. Find the x-intercepts. In other words, let's just graph this thing. Let's just graph it. What's the first thing you would do if you were going to graph this?
X plus 1, y.
wouldn't you put some dots on your x-axis? And where would those dots be? At -1 and at 3. And then I hope you would stand back and say, well, all together I have 3 x's, so this is a cube. How do cubes look? Where do they start? Cubes start down there, and they swiggle around and they end up here, right? End behavior. So I'm going to start down here. Now, what do I have to pay attention to? I'm starting my curve, I come up, I hit this point. What do I have to pay attention to? That's a bounce. Because that dot came from this, which is squared. So it's going to turn right around, bounce down. Right, what's it do when it hits that one? Goes up, goes right on through, because that one's not squared. Now, that's going to help me answer both questions. What are the x-intercepts? These are the x-intercepts. Those are the dots on the x-axis. Those are my x-intercepts. At what point does the curve just touch, or bounce, or act as a tangent? What point does that happen? Where does that happen on the picture? -1, 0. And why does it happen there? Because that is a square. Every factor that's squared is going to give you a bounce, right? Every single one. Okay. We did this one yesterday too. How do you find the inverse? So this is y. And then I switch, so x equals -2y plus 3. And then I'm going to get y by itself. So what am I going to need to do first here? Subtract 3. And then divide. And that is my inverse. Remember this notation. This means
Thank you.
find.
Pitching in.
Oh,
5 o'clock, he was here,
I
5,
know.
talking,
I
having
know. He
snacks.
said hi to me when he left. I know. It's
Thank
crazy.
you.
Okay. So, using my correct inverse, that's it. Okay? All right. Number 16. Write in exponent form. Now, that may be a little bit different vocabulary than you're used to. So let me remind you, what does ln stand for? ln represents what? Not e. Log base e. So this is log base e of 16 equals x. And I want to write that without a logarithm. I want to write that with an exponent. So I'm just going to log rule it. E to the x equals 16. And you're done. It doesn't say solve. It says rewrite this equation with an exponent. That means log rule it. Get rid of the logarithm. These two are the same equation. This is logarithmic form. This is exponent form. 17 we did yesterday. In fact, it's very similar to the one we did yesterday. We are going to write this as one logarithm. Make sure you're setting yourself up correctly. It's going to be ln something. So what's the something going to be?
8x squared divided by y.
What do you guys think about her idea?
Yeah.
Everybody okay with that? All right. Sketch. So we kind of just sketched a cube a minute ago, but we did it so that we could answer some questions. Now we actually are sketching it because that's what it says. So what are we gonna do? Take a look at this cube. Your job is to sketch it, so what do you think we should do first? People, every red-blooded American math student, any math student in the whole wide world is gonna do what when he sees that problem?
Distribute the app.
He's gonna factor it, right? He's gonna factor it. So how does that factor? We can take out an X. Now, whoa, what does that leave me with when I take out that X?
X plus 3, X minus.
X plus 3, X minus 3. Now remember, your job is to graph. So what good are the factors? What did that just do for me? That was huge.
A point.
It tells me that my points are gonna be at, these are my x-intercepts, are gonna be at negative 3, 0, at 3, 0, and
0.
at the origin. Always a plain X means the origin. Okay, now, 5 minutes ago, I said, where do cubes start? And you told me where? Right down there, right? So I'm gonna start down here. What am I gonna do when I hit that point? Go through it. What am I gonna do when I hit this one? Go through it. And this one? Done. You have graphed that polynomial. So if there's any piece of that you aren't sure about, you need to go back and study this. It's in chapter 2. All right, 19. We actually did this one yesterday too. What are you going to do with problem 19?
What road is he?
It's the guys that work here in the car, they do that.
Well, it's not Mrs. Ford in her room. All right, what do we do?
Log.
Log roll it. So 4 squared equals 3x plus 1. 16 equals 3x plus 1.
Yes.
And, where am I at here? So x equals 5? Everybody okay? All right, what about number 20? What are we gonna do with that one?
Foil.
Yep, we're gonna FOIL it out and then simplify anything that we can. So let's see what we get when we FOIL. First inside, outside, last. So 10 plus 8i minus 15i minus 12i squared. Okay, now what can happen at this point?
I squared to -1.
This is -1, so this becomes plus 12, which can add to the 10 and give me plus 22. And then these guys are like terms, minus 7i. And there's your answer. There is one multiple choice property question on the exam. One. It's up to you or not if you're going to study your properties. There's one multiple choice question. Number 21. What property is shown? What property is that?
Additive. Okay.
Will it be laid out like this for the final?
What are you talking about?
like like this question, you just said there's gonna be one property question,
Yeah, but it's not gonna be that same question.
but will it, like, the format of, like,
It'll say what property is shown. There'll be a problem and it'll have all your multiple choice answers. So what is this?
Community.
Yep, commutative, absolutely. Why is it commutative?
Yeah.
Because the order in the parentheses changed. When order changes, when it went from U plus V to V plus U, that is commutative. Okay? All right, number 22. I'm gonna go ahead and factor the last denominator as I write down the problem, because that's what I would need to do. I need to factor that,
Common denominator.
get a common denominator. So I'm gonna make all the denominators look like this. So this one's gonna get an x minus 2. This one's gonna get an x plus 1. And that one doesn't need anything because it already has those pieces. Now, some of you try to shortcut and it's fine, as long as you do it right. If you literally make all the denominators match, you can't go wrong. Because once they all match, then we just look at the numerators. So we have x squared minus 2x, that's that numerator, plus 3x plus 3 equals 5. Alright, and then what do we do with that? Yeah, and I'm gonna go ahead and move that 5 over because this is a quadratic equation and I'm gonna need it set equal to 0. And then what? Factor it. Of course, if it didn't factor, I could always use the quadratic formula. What are the factors? X plus 2 minus 1. So x equals, my answers are x equals negative 2 or 1. Now, these are the ones you do have to be careful. They could have extraneous roots. If you look up here, think about domain. X cannot be negative 1, and x cannot be 2. So if we happen to get those, we didn't, but if we did, we have to cross them out. Denominator can never be 0. All right, now we gotta, so right there, some of these have more than one part. Yeah, some of these have more than one part. So right there, that was the end of the calculator part. Okay, so now we're going, or the no calculator part. Now we're going to the calculator. List the possible rational roots. Okay, tell me what you want to do with this guy.
Split it.
So you want to factor it by grouping? And I'm okay with that, except, it's not really answering the question. The first question is list the possible rational roots. So what are the PRRs? Factors of 27. So 27, 9, 3, and 1. Over, factors of last, over factors of first. Now, I need to list these. So, I'm gonna do it organized. I'm gonna put all of these over 1. So that's gonna be 27, 9, 3, and 1. Because if I put them over 1, they're just themselves. Now I'm gonna put them all over 3. Well, 27 over 3 is already in my list. 9 over 3 is in my list. 3 over 3 is in my list. So the only new one I need to add is 1 over 3. And those are my PRRs. So those are the numbers that if I were going to start guessing and dividing, that would be the list I would do. Now Matthew says, I don't want to guess and divide. I want to just factor by grouping. We don't have time to do it both ways. I like to factor by grouping because it's faster. But if you were going to guess and divide, remember you're trying to get 0, this would be the list of numbers, positive and negative, that you would do. I'm gonna go ahead and factor by grouping, so I'm gonna take out a 3x squared, and then a 27. And sure enough, does it factor by grouping? Yeah, because we have a common factor, x minus 1. Now, what about this? Is there anything I can do with that? That's the leftover part. Take out a 3. Now, this is a little wacky. This doesn't factor. Why not? It's not a negative, it's not a minus. That doesn't factor. So from here, I have to figure out my solutions. What are my solutions? Well, clearly, x is 1. X squared plus 9 is 0, so x squared is negative 9. So what's x? Plus or minus 3i? The square root of 9 is 3, but it's negative 9, so it would have to be 3i. And there are the 3 solutions. All right, that's it for now. I can't squeeze another one in. So we're just going to keep on reviewing. Until we're done reviewing.